Here we have a problem on derivative. There is a function over here that is y equals to log of 1 positive x to the base a, and we have to find dy over dx. That is, we have to find derivative of this function with respect to x. Actually, it is a logarithmic function. Whenever I want to find the derivative of a function which contains logarithm, it has to be a natural logarithm so that I can find derivative easily. Okay, let's consider the natural logarithm of x. So whenever I write spelling ln for a logarithm, it is understood that is natural logarithm and its base is e. If I find derivative of this natural logarithm of x with respect to x, so what I need to do is first I have to write 1 in numerator, and whatever argument I have for the natural logarithm, I should write it in the denominator. So the derivative of natural logarithm of x is 1 over x. So when I have natural logarithm in a function, I can find its derivative easily. So, but here for this logarithm, the base is c, the base is a. So it's not a natural logarithm. So before we find derivative, our first work is to convert this logarithm to natural logarithm. That is the logarithm with base e. So what should I do for that? So for that, let me write the given function y equals to log of 1 positive x to the base a. Okay, to convert this logarithm to natural logarithm, that is a logarithm with base e, I have to write two natural logarithms in a fraction. Okay, so for the natural logarithm in numerator, I have to write this 1 positive x as an argument. And for the natural logarithm in denominator, I have to write this base a as an argument. So now I got the given logarithm in terms of natural logarithm. So then the given function becomes y equals to ln of 1 positive x over ln a. Actually, a is a constant. So when a is a constant, this complete stuff ln a has to be considered as a constant. Since ln a is a constant, it can be written separately. So when I write this one separately, it will be 1 over ln a times ln of 1 positive x. Okay, now I can find derivative of this function with respect to x. So when I find derivative of this y with respect to x, it is dy over dx. Okay, here, so in this part we have only constant. So a is a constant, then the complete stuff natural logarithm of a has to be considered as a constant, the whole fraction as a constant. So this fraction is multiplied by the variable, because here in this natural logarithm we have variable x, then the whole part has to be considered as variable. So a constant multiplied by the variable. When I find derivative, if a constant is multiplied by the variable, I have to keep the constant as it is, and I have to find the derivative of variable alone. Okay, when I find derivative of this natural logarithm, I have to write 1 in numerator, and in denominator, so whatever argument I have over here, it should be written in denominator. That is 1 over 1 positive x. So far, I have completed derivative only for this natural logarithm. By chain rule, I have to do further derivative for this argument. Okay, when I find derivative of this 1 positive x, first let's find the derivative of this constant 1 with respect to x. Actually, 1 is a constant. Whenever I find derivative of a constant with respect to any variable, it will become 0. And here, positive. And what is the derivative of x with respect to x? It's just 1. Whenever I find derivative of a variable with respect to itself, it will become just 1. So then I'm getting dy over dx equals to 1 over ln a times 1 over 1 positive x, and 0 positive 1 will become just 1. Okay, so dy over dx equals to 1 times 1 will become just 1, and ln a times 1 positive x. So I got the derivative of the given function. So this is the derivative of the given function with respect to x.